Hello and welcome back to another video of solving AMC 8 questions. Today we will be doing question 22 from the AMC set of 2020. So this question may seem complex because of the table, the graph, the drawing, and the arrows. However, if you just take the question apart and solve it bit by working backwards, you'll actually find that this question is relatively easy. So first, let's read the question. When a positive integer n is fed into a machine, the output is a number calculated according to the rule shown below. Okay, so n goes into the machine, and if n is even, then it would be n divided by 2. But if n is odd, it would be 3n plus 1. Now, for example, starting with an input of n equals 7, the machine will output 3 times 7 plus 1, which equals to 22. Then, if the output is repeatedly inserted into the machine 5 more times, the final input will be 26, therefore giving you a pattern shown right there. Now, when the same 6-step process is applied to a different starting value of n, the final output is 1. What is the sum of all such integers n? Basically, what it's trying to say is that how many different values of n can there be when n is the starting value and the pattern goes on and then the final output is 1. Okay, so let's read the question quickly again, but this time let's underline the keywords. Okay, so when a positive integer n is fed into the machine, the output is calculated according to the rule shown below. So let me just highlight the pattern. N divided by 2 or 3n plus 1. And that is if n is even or if n is odd. Okay, now moving on. For example, the starting output n equals 7. The machine will output 3 times. This part is not really important as to the rules and the regulations of the question because it's only an example. Now, if the same 6-step process is applied to a different starting value of n, what is the sum of all such integers n? Okay, so what are we going to do? We can work backwards. So how we might be able to do this question is starting from the final output, which is 1. So 1 is the final output. So what are the options for the n before? It has to be 2 because it's 2 divided by 2. There is no positive integer of n that can be fed into the machine and become a 1. So, what's the possible one before 2? It would have to be 4 because again, there's no positive integer that is odd that could follow the rules and become 2. It's just not possible. Now, when it comes to 4, there are 2 different options for 4. Now, it could either be odd and it would be 1 because 3n, where n is 1 plus 1 equals to 3 times 1 plus 1, which equals to 3 plus 1 essentially, which is 4. Now, you can also be 8 because, 8 divided by 2, we know that is 4. So that is the 2 different options. Now for 1 again, like we've seen here, it's like similar here. So it would be 2 again because you cannot find a positive integer. Again, make sure you read the question and you see the keyword positive integer. Therefore, it cannot be negative. Now, for 8, it can be 16 and only 16. Now, let me just move this further over there so we have more space. Okay, now moving on. What can we get from 2? We can get from 4, just same correlation from the previous calculations. Now, also make sure you're keeping track of how many steps you're taking. So right now we have 1, 2, 3, 4, and 5. So we can only make one more. Now there are two options for 4 as shown here. It can either go that way or they can go that way. So it would be either 8 or 1. Now you can no longer go forward with any of these numbers because remember, it's a 6-step process. So you cannot go over 6 steps. So these are the two answers or two possible values of n. But wait, we haven't finished on this side yet, so you can't continue with the question. So 16. Now, 16, what can we get from 16? We can only do 5. There is no even positive integer that can divide by 2 and get to 16. Now we can also do, sorry, that was my bad. There actually is, because you can do 32. You can do 32 divided by 2. That was my bad. Please ignore what I said before. And for 5, you can obviously have 10, as 10 divided by 2 equals 5. And for 32, you can do 64, because 64 divided by 2 equals to 32. There are no other options for either of these because it doesn't work with a positive integer that was negative, or not negative, odd or even for each case. Now, what are we going to do? Let's read the question again really quickly. What it's asking is, what is the sum of all such integers n? Now, what we've just figured out, what have we just figured out? We figured out 8, 1, 10, and 6. But what are these values? What do they stand for? Well, each of these values stands for a different possible scenario where these numbers, 8, 1, 10, and 64, are all the starting value of n. And since it's asking for the sum of all starting integers with the value of n, or possible ones with the finishing output of 1, all you have to do for the final answer is to add these numbers up. So you have to add 8 plus 1 plus 10 plus 64, which will give you the answer of 83. Okay, and is 83 an option? Yes, it is. It is E. Therefore, the answer to this question is 83. And make sure to understand the thinking process of working from the final output to the beginning. Because if you try to work from the beginning to the 1 or the final output, it might be a lot harder and maybe even impossible. So make sure to check your thinking and think in different ways to get to the answer. Thank you so much for watching, and we'll see you at the next one.